I'm Wesley. Today we're talking about Elasticsearch, mainly the analyzers. I don't want to get too into Elasticsearch because this topic can get really long. So just going to talk about the analyzers, how your data for your catalogs and what you're actually indexing in, what that actually means. Where's it going, how's it getting in there, what it looks like once it's in there, and how does it come back out. So again, that's me, Director of Development at Creativity. It's my Twitter handle, my email. It's on the last slide. I'll put it back up here at the end. See a couple people taking pictures. I'll wait a second. All right, so what exactly to expect here? So what is Elasticsearch? What are the differences between analyzed and not analyzed fields in Elasticsearch? What are analyzers and what are terms? What is the inverted index, and what is that mythical creature that somehow lives inside Elasticsearch that we don't really know about? And what should I be indexing when I'm thinking about search, and which fields are important? So let's jump into this. So what is Elasticsearch? First bullet point comes straight from Elasticsearch's website. So Elasticsearch is a distributed open source search analytics engine for all types of data. A bunch of different types. I'm really only going to talk about textual data, structured and unstructured data. The other ones are more for your analytics and things like that, where this is more for search and finding your products and getting the right products to your customers. So biggest point here is that it's distributed. So Elasticsearch is built on Lucene, same as Solr, but where it's different is the fact that it's distributed. So it's going to take all of that data that you're putting in, break it down into shards, which are basically sets of that data broken down, keep those separate, and allows it to search against each shard individually. Now you can also have replicas of those and for more scalability and things like that, but basically breaks it down so that you're searching with more processes instead of one. Think of them like hamsters, basically. So you can have one hamster in the wheel, or you can have 7 hamsters running in 7 wheels, and how fast can you get through this data and spit it back out? So under the hood, like I said, Elasticsearch is built on Lucene, same as Solr is, but it breaks it up into these clusters and into these shards. Lucene's the one that's doing the full text search, so the data structures and things like that, like inverted index and things like that, come from Lucene. Elasticsearch is basically powered by that and adding this extra ability on top. The clustering and the distribution, like I said, that's the ability to basically break your data down, distribute it. When we get into infrastructure and that side of this, I'm not going to get too much into it, but you can actually put your different nodes and different replicas onto different servers, so you have a lot more power behind what's going on and can serve this data a lot quicker. Like I said, Elasticsearch utilizes those data structures. The big one I'm going to talk about here is the inverted index. So the inverted index. It's this kind of crazy thing that lives behind the scenes in Elasticsearch and behind your terms when it comes in. So basically, it's going to break down every field that you're handing in that's an analyzed field, break it down into what it considers terms, or as most of us would call them, words, and basically index those words, know which document they live in, the frequency at which they're in there, and what position in basically the sentence or the phrase that they're in, whether it's the first word, the second word, third word, things like that. So, like I said, references which document they're in, the frequency, and then we're going to talk about not analyzed and analyzed fields. So we'll talk about not analyzed fields first, because that's a little bit of a quicker discussion. Not analyzed fields does exactly what you think it does. It doesn't analyze them. So you're basically going to take that whole phrase and treat the whole phrase as a word. So what that'll end up looking like is something like this. So I stole basically 3 titles from the test data that comes out with Magento. So let's look at these as product titles. Now you can do any field that you want, so descriptions, this all works across all of these, but I'm keeping it simple so we have a way of just looking at this. So what your inverted index ends up looking like is what we have here on the right. So you have the whole phrase. Obviously your frequency is 1 because it only shows up once. Now what this does is allows you to search directly against this exact string. It doesn't really help when we're talking about titles, so it looks a little bit weird, but it's very easy data for us to digest as humans. Where these non-analyzed terms become useful is when we start talking about things like SKUs and things like that, where we want to do exact string searches. So it's a little bit easier to think about when we're talking about SKUs. So what should this look like when we're talking about product titles is if we use a analyzed field, or the analyzed index. Ends up looking like this. A lot bigger, a lot scarier, but this makes a little bit more sense. So it breaks it down into each word. Second column is which document it's associated to. So you can see that they're broken down. Words like hoodie would show up in 2 and 3, listed as 2 and 3. Same with your position, what position they're in the phrase, and then the frequency at which they list. So words like hoodie, like I said, it's in the index twice, so it's going to let you know it's twice. Now, this is a very short data set, only having 3 documents. Elasticsearch is really good at doing many documents. So I'm talking millions of documents. So these numbers can get a lot bigger. You're going to have a list of documents that's a lot longer than just 1 or 2 like I have listed here. Try to keep it digestible, though. Maybe? There we go. So what is the analyzers? How do things get into that big crazy structure that we're calling the inverted index? This is where the big power and all the meat and potatoes of what we're going to do with our search terms and our fields that are going to go in. So it's a 3-step process. First step is basically a 3-step process. It cleans and tokenizes the input string. So first we'll look at the indexing process in. So your input string is going to be the fields coming from your products, your product title, your description, any other field that basically an attribute in Magento you would mark as searchable would end up being one of these fields. You can define the fields within the mapping, so whether it's analyzed, not analyzed, how you should handle those fields. In some cases, you're going to end up with some numeric fields, depending on what your catalog looks like, but it's not a very common case for search to see numeric fields there, at least for product search like this. So in this analyzing process, it happens at both the index time, like I just said, and at search. So when you're searching against this, you're going to put in basically a phrase into the search box and follow the same 3-step process to tokenize it, search against that inverted index on the same words that it found in your phrase, to then relate to the documents that it has related in the inverted index, and then return those documents to you. Clustering, of course, is how that becomes so fast, because you have multiple sets of that data returning multiple sets with a master node at the top that basically puts them all back together and gives you one result set. The analyzers, there's a ton of them built into Elasticsearch. There's a bunch that are languages. I think there's a little more than 60 different languages built in right now, plus a bunch of other term filters and character filters, which are the first and third steps of this. You can also add your own custom analyzers as well. So you're not just limited to what exists in Elasticsearch. You have the ability to add other ones on top of this. But like I said, handles things like localization, so your different languages. So if your product catalog's in a different language, words mean different things, different ways of breaking down those words. So there are languages out there that a word in that language actually looks like 2 words and has a space in it, but Elasticsearch will have the ability to break that up and know that those are actually the same word in the same term and put them together. Then you have your character manipulation and your term filtering. So step 1 is character filtering. What this is going to do is filter over the entire string that's coming in. It's looking for things like white space to reduce white space, bring that down to 1 space between, remove the extra returns, different things like that. You can add a analyzer here that would remove punctuation if you wanted to remove the punctuation from it. You can get analyzers at this point that will also remove things like HTML tags and things from your fields as well. So you're not just limited to just characters. I know it's called the character filtering, but you can also remove things like tags and things like that. Step 2, tokenization. This is the step that it goes and it breaks the string down into an array of words or what it considers terms. You only have one tokenizer at this point, where the character filters, you can chain as many as you want together, whatever fits for that field. Same with the third step, but this step, you only have one. This is the main one that is going to break this down and tell you how things are going to get into your inverted index. So usually is splitting up on space. I say usually, like I said, different languages are going to split up differently. So English, it's usually on the space. Other languages might be a little bit different. And then into the third step, you have your token filtering. So this is where it's going to do things like stop words, removing words like the, and, words you don't really need in there for search that we You don't want to pollute the inverted index width, because remember, we're going to have millions of documents in Elasticsearch. It means you're going to have millions of terms in your inverted index. Keeping that as small as possible helps reduce the amount of memory that you have and that you're using within your cluster. Also at this step, you're able to do things like filtering to either lowercase or uppercase. It kind of becomes a preference. It's just easier if we're filtering it to a standard. Usually you see it done everything to lowercase, because Elasticsearch will consider words. If one word is uppercased, it's the same word, but it's lowercase, it actually sees them as separate words. They have separate ASCII numbers, so it sees them as separate. So at this point, it will also filter out things like capitalization and stuff like that. Like I said, this step you can also chain as many as you need together, so we're filtering the data down and getting the terms the way that we want them in the most organic sense to put into this inverted index. So what does this look like now? This example kind of is a little bit hard to do because it's such a small data set. Really, the only difference here is where the got removed because it's a stop word. So you would see words that have special characters in them. If we had the special character filter in, those are going to get removed. You're going to remove HTML tags, things like that. It cleans out this term index, this inverted index, so it's just the words that we care about searching against. Where this also becomes a little bit different than what you would see for things like SEO and for search engines want you to use different words and a variety of words for things, which is why I picked the words I used here. Things like sweatshirt and hoodie can be considered synonyms depending if we're going to split the hair of whether one has a hood and the other doesn't. But for the most part, we can consider those synonyms. But Elasticsearch, because they are different words, is going to see them as different things. So you're going to end up with synonyms and stuff building beforehand to filter those back out, filter the words back down to the ones you want, and then pass them into your inverted index. A lot of the third-party modules like Elasticsuite and other ones that are out there will have synonym libraries pre-built in and different ways of handling those, however those modules have decided to do it. There's a bunch of different ways of handling that. So search time analyzer, like I said, the phrase that's going to come in from search is going to follow the same three-step process. That way, the terms that are coming in from search end up being split up the same way. If you have the option of using different analyzers at this point, but it almost doesn't make sense because if the words that are in your inverted index were analyzed a certain way, you're going to want to analyze the search term or the search phrase that's coming in the same way so that the words, you're going to end up with the same results so that it actually can compare them correctly. And like I said, it compares them against those words in the inverted index, returns the documents associated to them. It also will help build a scoring system against this so that we have a way of ranking which terms are more important based on the position and different things like that, frequency, so that the more important documents float to the top of your search, where if you mention a word only once in a large paragraph, it's not as important as if it's in there 10 or 12 times in the same size paragraph. So basically, we're going to look at the different types of data. So you have your text fields. Text fields can either, like I said, be not analyzed, which are like your SKUs and things like that, which fall into your exact match fields. Text fields, title, description, those are the ones you're going to want to break down, start building into the inverted index. Those are the ones that we need to pay the most attention to when we're trying to build these indexes, because it's not like taking a bucket of water and dumping it into the bathtub and hoping they all just fit. You're going to end up with a lot of words, a lot of ways of things being phrased and things like that, and you're going to want to watch how that all gets added so that the resources that you're using for Elasticsearch instances and the cluster itself, you're not running out of resources either on the memory or on the CPU to try to make all of this happen, especially at the time of index. So it can get a little complicated, especially when we have to realize this is a computed set of data. So it's going to pile all this in. All these numbers are calculated at that time. So we're used to in Magento talking about things like a partial re-index. It really doesn't exist with Elasticsearch. The way things get deleted in Elasticsearch is a little different. It's not an actual delete. They are basically added to a removal index so that the document itself stays, and it's also listed under removal. When it's searched for, it comes back up to that master node, and at that master node, it decides, okay, these are removal terms, take them back out. Doing the full re-index actually will clean that out and give you a full clean set of data again. So this becomes very different than working with indexes in MySQL, where you don't want to constantly be re-indexing. And when I say that, don't constantly re-index Elasticsearch either. You want to look at it depending on how often your data is changing. If you have data teams that are working daily on your data and they're changing them daily, you're going to want to look at staging it nightly so that you're re-indexing each night, having a fresh set of data to work against and a fresh set of data for your customers to search against every day. You do not want to be doing your re-index during the day. It's your peak times, you're going to slow things down. It works the same way as the other talk earlier with caching and with indexing. You will slow your site down if you're constantly redoing this stuff. Now, like I said, there's numeric fields. So these are your I call them non-fluid numbers. These are the numbers that are not going to change often. So the ones you see changing often are price and stock, usually. Don't index those. They change too often. You're going to be dealing with the issues of deleted documents, updating documents. It's really hard to work with those then. And they're not really suited for this type of a index in Elasticsearch. But you do have numeric fields like product rating or comment count, depending on how you want to search it and how you want to base your scores. So if the number of comments or the amount of times that a product's been rated is meaningful to clients, or you want them for a sorting ability, so that the more rated products filter up to the top and bubble up to the top, you're going to end up using a numeric field to help calculate that and help populate that. And like I said, attributes you do not want to index. Price and stock are the two examples I have. It depends on your catalog data, what data you have and what data you're trying to actually search against versus what's just a product attribute and doesn't belong in Elasticsearch, which should stay in MySQL. So in conclusion, like I said, Elasticsearch, full text search, based for analytics, built on Lucene, gives us a lot of power for that full text breaking down of words and analyzing the words themselves, where if we did that in MySQL, you're doing the full table scans and all those scary things that we try to stay away from in MySQL. Analyzed fields are the fields that are processed by your analyzers, broken up, tokenized, and set up for search based on the different words that are used, where you're not analyzed are the ones that, well, are not analyzed. They're just direct strings. The analyzers themselves are that process, breaking them up, making it usable, tokenized. Your inverted indexes are the main beast behind all of this. It's where everything's stored. It's how everything lives. It's kind of this hidden data structure behind all of that. And then lastly, your non-fluid fields are the ones you should not be indexing. Everything else is based on whether it's actually going to be used in search or not used in search. So like I said, I put this slide back up at the end. I kind of intentionally left this talk a little bit shorter because I figured there's going to be a few more questions, because Elasticsearch and building these search indexes, this inverted index, is very based on your product catalog, your client's product catalog, and what information you're actually trying to search against and why you're trying to search against it. So I'll open it up to questions.
Fantastic. Let's hear it for Wes. Nice work. All right, who has a question about? I knew it would be everybody. All right, we'll start over here.
Does Elasticsearch support situations where, with word groups, or like in your example, hoodies are sweatshirts, but sweatshirts are not necessarily always hoodies? Does it support something like that?
That's going to fall more under your synonyms and how the synonyms are built. So like I said, different modules are going to handle synonyms differently. I'm most familiar with Elastic Suite, which is the open source one that's out there for Magento now. Everyone handles them differently, but in Elastic Suite, there are two different types of synonym libraries. There's one that's a directional and one that's a non-directional. I think what you're talking about more is like a directional one where sweatshirt equals hoodie, but hoodie does not equal sweatshirt.
Right.
Where the non-directional one means they're interchangeable either way.
Thank you.
Yep.
All right, who's next? I saw several hands go up initially. Did that answer? That answer blew out everybody's questions. Oh, here we go.
So for something like a natural language filter, something like, hoodies under $400 or black hoodies under $400, where it's numeric and full text, would you have multiple analyzers for that, or would you use a single analyzer for something like natural language?
Things like that, would you be expecting the customers then to, in the search field, say hoodies under $40?
Correct.
I'm gonna be honest, I've never actually looked at that kind of use case. Usually you would put your prices on your filtering, which ends up happening as a step after what Elasticsearch has returned to you. So the facets in which you would normally see on your result page is where you would filter down to the ones that are in the price range you want. So it's kind of an interesting question. I've never looked at how that would play out.
Maybe it's a bad example. How about something like black hoodies for big men to filter on size?
That's honestly going to be how your product data is built. So if your descriptions are saying that this hoodie is for big men, then it's going to be able to pick up that it's those words are prevalent in the description. Those are the documents that are going to bubble up to the top more. So it's a matter of whether you're actually calling it out in your product information or not.
Thank you.
Yep.
Awesome. Who's next? Got a question up front.
Getting your exercise today.
Just to clarify what he was just asking, I think what you're saying, if I'm correct, is that Elasticsearch doesn't support natural language, so you would have to structure your data in a fashion where you'd be able to pick up on things where for big men means sizes 9 through 11 or something to that effect, right?
I'm not sure I understand your question.
All right, well, he was asking about natural language and whether or not Elasticsearch supported natural language, which is basically breaking down a sentence into more specific search terms.
Right.
So at that point, you would maybe create some sort of synonym list where for big men actually could that be turned into something like a specific subset of sizes? Or again, you would have to do that after the initial search was returned from Elasticsearch. You'd have to do some secondary processing to filter that.
If you were looking for specific sizes, that would probably end up falling under your specific filters at the end. It's a little more like price, where you're going to have on that filtering, the left nav filtering on your result page to pick which sizes you want to filter by. What I'm saying with the language like we're talking now, is if we use the phrase for big men, for is going to most likely get pulled out as a stop word. So that won't even fall into the inverted index. Then you'd have big and men in your inverted index. Because it's also keeping track of position, it's going to know that those two words were next to each other. So it's going to float those two words closer to the top when they're next to each other. Then after that, words with big and then with men, just because big came first in the phrase. Does that make sense?
Yeah, thank you.
All right, we got time for about 2 more questions. Who wants them? Anyone? Oh, I know this guy. I run for my CEO.
So what's the biggest mistake you see people making with Elasticsearch, specifically with their product data?
With the product data itself, like I said, it's going to come down to the terms that you're putting in. So what I end up seeing is a lot of extra words getting put into that inverted index, where the inverted index becomes extremely bloated, and then you end up with infrastructure teams upset with you because you're using way too much memory to host all this data. It becomes very expensive to host then, and most of the words that end up in there never really get used. So it's a matter of grooming that data and making it not, oh, I got this CSV file from a manufacturer, I'm just going to dump that in as product descriptions and hope that that's relevant enough to be able to power search, where you should have a content team writing those descriptions and using meaningful words, so that the words that are actually in your inverted index are words that get used.
Okay, last question.
Have you seen any memory leaks in Elasticsearch?
Memory leaks. going to say sort of. That comes back to what I was saying with deleted documents. So what I end up seeing is people trying to use Elasticsearch as a partial re-index. So documents end up getting put into that deleted index, and you start getting the overhead on the inverted deleted index that's in there. So when all the group data comes back, that master set of these are the things we should remove becomes a lot larger than the data that you actually are searching against. And it starts to use a lot more memory and in some cases more CPU, depending on what it's trying to do. I'm not sure if we would actually consider that a memory leak, because it's not actually Elasticsearch's fault. It's more of what you're doing with it and like user error at that point. Prevent the user issue. Pushing for, like I said, staged content. So you're going to want your merchandising teams to be doing their changes during the day, stage that content to go out at a certain time, and then that staged content gets re-indexed at the time of that release. That re-indexing process, because of the way most modules work, I say most because not everybody's the same, but the ones that we should be using are going to dump that old index and build a whole new one for you, which means all of those inverted indexes attached to it also get dumped, including that removal index. So you won't see it bloating up because you're re-indexing it more often. For more organized teams, yes, you could do that as a cron job. If you don't have such an organized team and they're not specifically, like if you wanted to set, 1 a.m. Eastern Standard is when it's going to re-index, and if you don't get your changes in by then, you have to wait till the next day, then yes, you can do it as a cron job like that. Or if you want someone as a release manager so that they can work with the team and say everything that has to go out for business rule, we're going to re-index when we're done with it.
Fantastic. Everybody give it up for Wes one more time.
All right, thank you.
Thank you.